Hello, everyone. Can you hear me okay?
Yeah, I can hear you, and also I can see your slide. Everything is clear on my side. And if everyone in the webinar can confirm, you can hear Ignacio and also are able to see the slides.
In the meantime, I'll take the chance to introduce myself briefly. So, as Cesar said, I'm Ignacio. I also go by Nacho, full name Ignacio Alonso. Part of the Altair team, currently a senior solutions engineer of Altair and focused on EDEM. And I'll be running you through today a different way to post-process EDEM results, in particular, rendering them with Inspire Studio.
However, if you have any question during the webinar at any time, please let me know in the chat. So I'll pass it to you, Nacho. Thank you.
Perfect. Thank you very much. So yeah, it'll be quite I would like to think, brief session. The idea is first to go through a couple of slides covering a bit what is Inspire Studio, what is rendering, what's the main workflow, what are the things that we can actually do for this alternative way of post-processing our EDEM results, mostly from a visual perspective, and then we'll jump into a hands-on demo in which I'll take an EDEM simulation after it has finished running and walk you through what I would do to get a quick and high quality rendered image or even animation. So let's get started. First, just as a bit of an overview, what are the different types of post-processing that we can do with EDEM results whenever they are actually run and simulated. So first of all, and the one that most of you will be familiar with if you are EDEM users at the moment, we've got EDEM Analyst, so the kind of built-in post-processing tool in which we will mainly do all of the analysis for our simulation results. We're able to do coloring, graphing, visualization with different displays for our bulk material, exporting data, so kind of the main thing to get the actual information out of the simulation. And we can also get images and animations out of the analyst itself as well. Now, apart from this, we also have EDEMPy, which is a library of Python functions that are able to read EDEM data. So generally speaking, this can be used to export data and get data in different formats to what the analyst can provide. That's by default. So it expands even more the possibilities when it comes to exporting and post-processing the data obtained from the simulation itself. Then we have Inspire Studio, which is what we're going to focus on today, to be able to create high-fidelity visuals. And last but not least, we also have Hyperview, which is mainly used whenever there is a coupling case, for example, with an EDEM motion solve couple simulation, and you're also able to do the post-processing of the coupled results, mostly being able to post-process the motions of data, and at the same time do a bit of EDEM post-processing or being able to visualize it together. So that's a bit of a general idea of the different ways that you can go about post-processing EDEM data. And we will focus on the third one of those, Inspire Studio, today. But before we get to that, for anyone that may not be very familiar with EDEM or with the EDEM analyst, the default way to do it, and one that is still relevant and important to keep in mind, is actually using the EDEM analyst, in which we can do our qualitative and quantitative as well analysis. On the one side, we can just do coloring to different attributes for our geometries and our particles, which would be that qualitative side of things, using sensors and bins to get data exports for a more quantitative approach. We have the possibilities I was saying earlier of getting images and animations out of the analyst as well. And in general, is the most extensive and detailed way you can get of post-processing, at least in a straightforward way, from GUI. The nice additional thing that it's good to touch on from now is that we can use opacity modifications in the analyst to reduce opacity of certain elements, and also use clipping planes, which in Inspire Studio can be done for modeling of 3D objects, but not necessarily for renders as of now. So yeah, just something worth keeping in mind. There's tricks around this that I'll touch on, but yeah. And next, it's worth also introducing Inspire Studio first. As Cesar said, just a brief reminder, if anyone has any questions at any point, please feel free to drop them in the chat, and I will get through them probably before the demo if there's any, and then during or after as well. But let's move on then and cover an introduction to what is Inspire Studio. So pretty much Inspire Studio is mainly a different Altair software solution focused on enabling designers, digital artists, architects, and engineers to create, evaluate, and visualize design ideas faster than ever before. Mainly, it's a workspace that has sketching, the possibility of creating smooth curves, surfaces, 3D objects, and complex freeform shapes with a nice tool called Polynerves. And what's probably more relevant in today's case is the fact that we can actually get high fidelity visuals through rendering with their engine, and in this case for EDEM data, but for other software or simulation solutions, you can also render them as well if it's of interest, all within the same environment pretty much. So, having briefly introduced Inspire Studio, what are the benefits actually of using Inspire Studio for rendering our EDEM simulations? First of all, it's a great addition to what you actually get out of the analyst. So from the analyst, you're going to focus more on the post-processing of the data. This is a way to get the best possible visualization of your model and simulation, which can be quite handy when it comes to showcasing your solutions to customers, to management, and so on. It's actually very, very efficient in importing a very large number of particles. So generally speaking, the number of particles that you run in EDEM, it's feasible, to my experience, to just import it into Inspire Studio. It tends to be quite fast as well due to the method they use for representing them, the different particles. And then the additional things is, first of all, when you are importing your EDEM files, your geometries will also be imported with it. So you get directly geometries in, but if you want, you can also import your own geometries as a separate import. And last but not least, we're able to visualize things almost as if they were real for systems that potentially may not exist. So in many cases, we use them to run systems that already exist to look for improvement and optimization on the actual process, but many other times the equipment or the design is still in a conceptual stage and we're just simulating before any kind of manufacturing takes place. So to be able to visualize the actual system in its environment can actually be quite powerful and handy as well. Now, the main workflow, and we'll obviously cover this in the demo itself, but it's worth just to give you an idea of, it's pretty much 6 steps that you have to go through. The first one would be a 7th, but because you need to do any kind of EDEM simulation to be able to move on to the other 6, I didn't count it in. So first of all, you finish running your EDEM simulation. Once it's finished, and you do any kind of analysis you want in the analyst, if you want to get a rendered high fidelity visual from Inspire Studio, first thing you need to do is open Inspire Studio. It's kind of a half step, but we'll count it as 1. So open Inspire Studio. Then we need to open or import our H5 files from the actual simulation, as we'll see in the demo. We have to set up the materials for each geometry. So what I mean by this is set up the visual representation for them. There's a material library, and you can also create your own materials in order to display them and render them in a way that is as accurate as possible when it comes to being or looking as real as possible. Then we have to set the environment and the lighting. There's easy and simple ways to do this, which is what I will show you today. And then if you want to go into the advanced mode and set up manual lights, it's also possible. Define the render size or resolution. So if you're looking for an HD image, that will be a width and height of 1920 by 1080 respectively. But if you want a 4K resolution image, because you know that your animation or image is going to be displayed in a 4K monitor, then you can also render at 4K without any issue by setting the width and height of pixel counts yourself. And last but not least, we need to render the animation or the image, and we will have our render done. So I believe we saw earlier what the analyst would look like in the EDEM analysis slide. Some other things before moving on to what we can get actually in terms of visualization in Inspire Studio, even though I'm sure you have potentially seen some already, would be some of the additional features that there are in terms of nice little things that sometimes you can forget about. In the first place is that we can import any of the particle shapes that we use in EDEM. So we can visualize in Inspire Studio single spheres, multispheres, polyhedrals, and spherocylinders. There's no limitation in that regard. And in addition to that, in the same way as we have in EDEM a way to replace for post-processing our multi-sphere particle with a template so that it looks a bit more real, but while benefiting from the computational advantages of having a multi-sphere particle. We can also do the same in Inspire Studio. So we can run a simulation with multi-spheres. And then when we bring it into Inspire Studio with that little button that you see over there, particle geometry, we can replace the actual multi-sphere particle with a template so that the visualization just changes to the template for all of them. And we get our render with whatever template we wanted to use, with automatic scaling as well, which is quite nice. So what can you actually get out of Inspire Studio? At the moment, there's two different things you can get out of it. There would be an option A that's less common, but still something that it's currently being worked on and will get additional features. Is the fact that we have an attribute display. So similar to when we are doing coloring in EDEM, we can actually color the bulk material at the moment as well for a limited range of attributes. So I believe it's a velocity, angular velocity at the moment, but that's an option. The thing with it as well, the other limitation is that it's only available for not the full rendering mode, but a preview rendering, which is what you can see in the slide on the left. And then we have the main attraction, let's say, or the main thing, which would be the high fidelity or photorealistic rendering that you can get out of the simulation results with a bit of setting up that we will cover in a moment. So before we look into any potential questions that may have come in, just thought it's worth covering some other examples that may inspire your own imagination of what you could do with your potential systems. Hopefully the videos are coming through okay. So generally, any industry this can be applied to, any industry that we have, or any simulation, to be honest, that you run in EDEM. So we've got here some examples of a silo discharging, blast furnace charging, that blast furnace with quite a high number of particles, 10+ million in that stage. A SAG mill as well, with the differentiation between the steel bolts and the mineral itself. Might be lagging a bit, so the video's in it. Fluidized beds, dump trucks, unloading, tablet coating. To be honest, the possibilities are endless. You even have little tricks, like in the case of the tablet coating. Here, revealing all my secrets at the moment. In the case of the tablet coating, for example, the way that this simulation was run was to highlight the new ray tracing post-processing capabilities for coating, which allow us to just in post-processing get intraparticle coating profile. So for the visualization of this one, we could use, or what we did in this case was create literal cones as geometries directly inside Inspire Studio. And those cones then I've given them the material properties to be translucent. So you can see that kind of beam being casted over it, with the beam matching the one used for ray tracing. So yeah, there's always like little tricks and things that you can do to improve even the visualization from what you were getting in the EDEM results. And then just 3 more before moving on to the live demo. One that I quite like and I am quite proud of, the Robomower or lawnmower, which originally was created by my colleague Eric Bakel. Beam blender and off-road mobility as well. So being able to just model vehicles, they tend to look quite nice as well. And even with terrain beds, as you can see there. So before we move on to the live demo, we'll have a quick check to see if there's any questions. I don't know if you've spotted any so far, Cesar.
No, we don't have any questions so far.
Okay. Then we will move on to the live demo then. Hopefully everyone is pretty clear with everything so far, which is why there's no questions. So just to demonstrate, let me drag things through. Oh, fine, there we go. Where things are. So this is our EDEM simulation. After it's finished running in the analyst, we would have done all the post-processing, even set up all the colors for everything. And the idea would be to get something along those lines, but with the high fidelity visuals that we can get out of the Inspire Studio setup. So let me move that back and bring Inspire Studio through and walk you through the actual process. There we go. So can you please confirm that what you're able to see right now is Inspire Studio on an interface in white with icons in gray at the top?
Yes, I can see it, Nacho. And
Perfect.
for hopefully everyone else can see as well.
Perfect. So
also, Nacho, before we continue, there is a couple of questions. One, if you can let us know, where can you get both installers, either EDEM and Inspire?
So both are available from the Altair marketplace, for which you just need an Altair One account. Both installers are there.
Okay. Yes, and also just to let you know that once we complete the webinar, I will follow up with some information, including the link where you can download the installers from Altair community.
Perfect. So then let's continue. And the first thing that we need to do after our EDEM simulation is done would be go to File, Import, and from here we just select a time step from, well, actually, let me once again. So this would be the data folder that we would have within the whatever our EDEM simulation is. We go into the data folder, we choose a time step, any, because when we are actually choosing what time step we import is over here. And then we go to choose how many of those time steps we want to import out of all the ones that we can find in that data folder. We have 250. It doesn't take too long to load the 250, but just to be a bit quicker, I'll set it to 150 or 155, doesn't really matter. And then you can also step the import. So instead of getting a file or an import per file, you can get one every 2 or one every 5, for example. So yeah, we'll just import it. You'll see over here a little progress bar. She's going to be importing over time to have a reference of what we were using when it comes to colors, more or less. That's our file imported. Same simulation as in EDEM. Give me a second. So we will have now our transfer chute inside, just a system representative. Again, any kind of system or industry is applicable to this. Have imported our files, and we will have a 0.h5 folder over here. So if we expand it, we can see that we have what's called Animesh, but secondary thing, all of the different items that we had inside of EDEM. So different particle types and all the geometries or merged geometries that we were using. A nice thing to note here is we actually have a combined simulation in which we have multispheres on one side and polyhedrals on the other, using 2023 with different shapes being the possibility of having different shapes inside the simulation. First thing that we need to do, as we were saying in the 6 steps in the slides, would be to choose the materials that we're going to use for our different geometries and equipment. But before we do that, something that I always like to do, because I'm not a big fan of factories showing, is actually hide the factory 1 and factory 2. So we can hide them by just clicking on the icon over here. Those two are hidden now, and we can move on to selecting the materials by going to the rendering tab. We go to material, it will open a panel that is empty. Now, the way to do this, there's two methods. You can either select a material from the library, which I will cover first, or create your own material. The way to create your own material is the one that we're seeing. Well, I may do the create your own material just now. So the one that we're seeing at the moment, if you go to rendering material, there's nothing selected. If you choose something, then this control panel will populate and we can create a new material. So in this case, we're creating a material for the particles, and for it, I'm just going to create a brownish reddish material, iron ore like, in which I don't want it to be reflective, so I'll set this to 10, for example, and a roughness of 50. Just to give it a bit of a texture and finish. Pretty much anything reflective, you want high reflectivity. If not, you want low reflectivity. The roughness does add a bit of little roughness to it. So that's our material set. Now, the way to go through with the material library would be by going to this materials tab. And here we have now our material one that we have defined for the particles. You can expand and see particle 0 here, and the rest of materials without a material. And underneath, we have the material library that has all the different materials that are already preset that we can click and drag into our simulation or our workspace. So particle 1, we want it to be the same as particle 2. So if we right click on it and we go to assign a material, we can assign material 1. And both of those are now set to be material 1. And then the rest we need to set as well ourselves. So I know that the floors, I want them to be a grayish color. To be honest, kind of what the default is. We'll change it a bit. About there, and let's make them reflective. Now, you might be wondering, what is going on? All I see is still gray. So I'm doing everything in the display shaded mode because it's easier to handle. You're not putting your machine to stress to render stuff. But if you want a preview of what you're doing, you can activate the rendering mode by clicking on this button over here, and this will change to what you're actually rendering based on the materials. You could use the real-time preview, but generally speaking, you get a better understanding. Go ahead.
Hi, Nacho.
Sorry, so there
would
was
be okay just to ask you a couple of questions?
Yep.
So we're seeing here rendering the material and the geometry. Is there any limitations of how complex your geometry can be? And if
no
limitations, and also how complex that geometry can be in terms of rendering, will take that too long? If a geometry is very complex with too many items and geometry parts?
I'm not the biggest expert on how the code works, but I can tell you from my experience. When it comes to geometry complexity, it doesn't tend to be, if EDEM can handle it, generally speaking, Inspire Studio can as well. Once it's imported, it will be imported as a mesh based on the information it was getting from EDEM. The good thing of getting the import from EDEM, by the way, good to touch on this now, is that anything that comes from the EDEM time steps is going to update the position, orientation, and everything else as it would in the EDEM simulation. So any geometries that are moving are going to move like they were moving in the EDEM simulation. Any particles are going to move like they were moving in the EDEM simulation. If you import your own geometry, that geometry is going to be static because it doesn't have a motion assigned to it from the simulation itself, which in some cases like this one, you could potentially place something that is static, but in many others might not be as useful, like when we saw the off-road mobility flex tire track that was going in the last slide. If we put something there for the car, it's going to stay at the beginning, so it's not as useful. Then when it comes to rendering, sorry, just to cover the second part, when it comes to rendering, the complexity is mainly on how many different materials you have and how much of those materials is within the frame. So generally speaking, if I render this transfer shoot like this, forget about the half sphere here, we'll touch on that in a second. But there's a lot of gray space, there's a lot of white space, and then there's a bit of like blue and gray with the actual transfer sheet. This is going to render much faster than if I have a very zoomed in into the particles image. That's because a lot of pixels need to be rendered in gray and white, which is way faster for, in my experience again. For the engine, it just goes through and then it will focus on the area that has the different colors and shadows and pop those. In this case, being small, it's a small area that it needs to cover. And if we did something along the lines of this, it's going to take much longer to take into account all the reflections, the different textures, the shadows, and so on. So hopefully that answers the question.
Yeah, thank you very much. Yeah, I think it does, and we could see the applications earlier on where there are some complex geometry there. There is one more question before we continue with the presentation. And in EDEM, we know we can simulate and see the wearing the equipment. Can we see that when we're doing the rendering in Inspire?
At the moment, there is no possibility to display attributes such as wear on geometries. This is something, however, that is being looked at by the team to see if it's possible, and if it is, looking to potentially implementing it. So at the moment, no, but there is a possibility that in the future it may be possible.
Yeah.
No guarantee. So yeah.
Thank you, Nacho. So we continue, and then more questions that come up, we can do it after this part of the presentation. Thank you.
Perfect. So I'll just continue with any parts that require a material to be created, like customized, which, if I'm not mistaken, it will be this transfer shoots, and that's about it, with the addition of hiding some of them. So for the transfer shoots, we want a darkish blue color. It's going to be the Altair blue. I don't remember the exact color code off the top of my head, even though I should by this point. And for this case, we are going to leave them as reflective as well. So the reason why I was setting up the materials earlier on the display and shaded mode is because it was faster to avoid things like the poor engine trying to render the changes I make on the spot. So we'll do that, and then we'll change to see how it's looking. So apart from that area that we already have changed, we have shoot parts 3, shoot parts 2. Sorry. That might be, and shoot to hide that we're going to hide. So again, assign material 3 in this case, is the last one that we made. And then if we go into the actual list of parts, we can hide the shoot to hide to match the one in EDEM. So now, if we go into the preview, I should probably save this as we go, to be honest. We have all of our dark blue transfer shoots set up. Let me go back to shaded and save this very quick. Name just to have something to go back to in case there anything goes wrong accidentally. But yeah, so those materials are ready, and now let's go into the library to set those up. So within the material library, we have quite a long range of different materials. Some are not as applicable to EDEM applications and industries, but it's still nice to have all of those and the additional options of creating your own materials. I'll briefly touch on, I won't go into detail for it, but I'll briefly touch on the creation of, if we wanted to, for example, belt 3, create a material for it. We've been looking so far at the creation of basic materials, which is what I would recommend starting with. But if you want more possibilities, you can go into full and you can create your material, first of all, choosing between if you want a metallic finish, a glass finish, glass material, some kind of coating, metallic flakes, if it's a light emitter or a shadow catcher, etc. So you get quite a lot more flexibility in terms of what you want to create. Generally speaking, with the basic is enough, but in case you want to go a bit more in depth. And then with the material library, as we were saying, first of all, we want to set a material for, let's remove this one and assign it. This is the one that we didn't actually do anything with it, and delete it. And let's go into rubber from the material library and choose soft black rubber for belt number 3. That because I have something selected, it's not letting me. There we go. That will be the particles. That should be the belt. Yeah, there we go. So whenever you use some material from material library, the rendering engine is going to kick in with the preview. So we have the soft black rubber set up to belt 2 or 3 or 4. Now we have all the other belts that we need to give the same material to. So we select them all with control, assign materials, soft black rubber. So all the rubber is set. And then we have the belt walls that are going to be, including the deflector plate as well, they're going to be a metallic. We have a range of metals to choose from. In this case, we can just choose iron, for example. If you want something more bright and shiny, you can choose aluminum or aluminum. You also have the mirror option. You want something that is very, very reflective. But in this case, with iron is enough. And again, for the deflector plate, actually, for the deflector plate, we could put the same, but let's just, for a bit of variability, put not very realistic, probably, but cast iron on it. Maybe a bit too dark. Let's make it out of brass, not very realistic. At least it will be a bit more easy to visualize. Go. Okay, so that's all of our materials actually set. That's step 1, and it just goes faster and faster from here. Next thing that I would do is set an environment. So again, we can go into the environment tab, or we can go into this little one to look into the environments. We have a range of different environments that are previously set. They will matter for 2 things. One is the background that you can actually modify manually as well. And the other one is the background. You can get one of the ones you see over there, like a desert background, Empire Square background, a whole background, parking, if you want to. But then you can also set the background to be white or a specific color. And the other thing is the lighting. The lighting conditions will be reproducing the ones in the environment as well. So if you use the beach sunset, you have a sunset-like golden hour lighting. And the soft boxes will give you a softer light with softer shadows. The ones of studio tend to have harder shadows with the light and shadow areas, not having any kind of differentiation in between. So it's a matter of choosing one that you like for your scenario. Just to showcase the environments, if you choose one and you want to show the background, you will need to potentially move it around. That's going to apply. Let's click there. But yeah, if you click and drag one of these, it's going to apply the lighting and background to it. But before we do that, the way that I normally do my renders, and what I would recommend to start with, is first of all, well, you can see the sand in the bottom now from the environment. You can shrink it, you can maximize it, you can turn it, so it makes sense with what you're actually doing. In this case, we're going to select custom background map from the environment section to be white, because we want a white background, even though we still may want this light. And then it's a question of, do we want shadows? A very simplified question of, do we want shadows in our render, or do we want our render to be kind of shadowless, standing in nothingness? A bit less realistic without shadows at the bottom, but at the same time, it is easier to get it into presentations if you're doing any kind of presentation with your render. So if you want any kind of shadowless, might be easier with a different lighting. So we click here as well, double click actually, click on the arrow, I believe. We should get a pop-up window to select a different environment. Doesn't seem to be helping me out now. So I'll just drag and drop another one, a softbox. See the difference in lighting, and to set it up for having no shadow. So you can see the shadow at the bottom over here, with a clearer view as time goes on. And if we change this from being a finite dome to being an infinite sphere, we will remove those bottom shadows and have a cleaner edge around everything. So again, putting it into a white presentation or a color presentation, change the color of the background to match that one. In this case, we'll go with something along these lines. So we have lighting, we have our material. The other thing that I would generally recommend doing is setting up the dimension. So you can mess with the focal length if you have an idea about photography. Pretty much, it's just going to extend the background, making it, we reduce it, for example. It just changes the angle that you are looking at objects with, gives you a bit more perspective sometimes, depending on what you do with it. Can be a nice option. And then what I would recommend is always changing the preset to be HDTV 1920 by 1080 to get an HD image, at least. And if you want to increase the resolution or change it because you have a long aspect ratio vertically, for example, system like the fluidized bed, then you can reduce the width, increase the height, or change it to be 4K by setting the 4K measurements and width and height of the pixels. So that's one thing. On the engine side of things, the only thing that I would recommend checking is that you're running your render in your actual GPU, whatever you have in your system. This being a laptop, so this Quadro T1000 GPU. And pretty much, I would say the main steps are covered. We could render this image and it's already looking quite nice. The one thing to touch on before clicking on anything would be the animation options. Now, in some cases, by the way, because of what we were saying earlier, of not being able to clip during a render, it's worth planning ahead what you want to do with the render. So if you want to have any geometries be their own entity, to be able to hide them, as I did earlier, that's one option. So for example, if you have a system that it's a closed system, like tablet coater that we were talking about with the cones, that tablet coater is fully closed, but I made sure to leave a circular lid that I could hide to be able to look into it. So that's something worth keeping in mind. Now, when we go into the animation panel, animation mode by default triggers, and this animation mode just gives us a time frame of how many seconds of simulation we have imported based on the H5 files that we import and the keyframes. Now, we can play through the animation, but because the rendering preview doesn't update quick enough to be able to see the animation, if we want to see the animation before rendering it, we need to press the display mode, shaded mode, and now we can view it, or if we press view, it's going to automatically change to the shaded display mode anyway. So this is the animation that we have, and we can change a couple of things, mainly the amount of total time. We can reduce it if we want to not do the full thing. We can change the frames per second. This will be set by how many save intervals you actually have in your simulation. If you have a lot of save intervals, you can actually do a very, very high frame rate. It's generally not necessary. Generally speaking, 20 to 30 frames will be more than enough. In cases like this for animation, even 12 can do it. And it will also be faster to render because what you're rendering is each frame. So the more frames you have to render because of a longer period of time or because there's more frames per second, the longer your render will take to finish. Once you had your render set up, if you had your camera angle as well set and you wanted to render that, if you want to know how big your render is going to be, by the way, everything that is inside the dash lines will be in frame, anything outside will not. This is based on the resolution that we said earlier. And we would click on render, save the file. There's a nice option to kind of do save points in case that anything goes wrong, of saving the frames as PNGs, and then you start rendering one by one, frame by frame, to get an animation at the end when everything is done. In the case of getting an image, we can either render directly or render in darkroom. Render in darkroom gives us some post-processing on the image options in addition to being able to get it as a fully transparent image by saving it as a PNG plus alpha channels. For this case, on this example, we'll quickly just get a render through. So click on render. Let's give it a second. Any questions so far, Cesar?
One more question at the moment. How big are those video files?
The video files don't tend to be, I would say they're normal sized. They're not massive. So in EDEM, for example, if you don't compress your exported videos, they can be quite large in size. These ones, generally speaking, are just like a normal video. It will depend on how many seconds you have and like what you're actually rendering on it, but it's not like something crazy.
Yep. Are we waiting for the rendering?
I'm waiting to see if it triggers, and if not, I'll do it in darkroom.
That's fine. I think I'm going to ask everyone a question just now while we wait for the rendering. The question is, how familiar are you with EDEM? Yeah, so currently we have a mix. So some beginners. Most of you attending the webinar today are intermediate and some advanced users as well. So thank you for your answers.
So you can see over here, it took 32 seconds to render the image. It's still finalizing the file after, well, it just finished over there. Actually, it took a minute 14, 32 seconds to do the rendering. I think a minute 14 to sort it out, being on my laptop. So here you can save the image directly. So select location, file name, file type. You can go to darkroom if you want to do what I was saying of saving it as a transparent image for anything white in the background. And that's how you get an image rendered, pretty much. Very nice and easy and quick after doing the setup of materials, environment, and scale or resolution. And as I said, we don't want to save the render, it's okay. If you go to the animation and you press on render, the same would happen. It's just that you need to save frame by frame. So we did a frame now in a minute. You had 50 frames, might take 50 minutes, depending on your hardware, your camera angle, how much white space you have. What I would recommend is to save the frames as PNGs, since you can always use them as an image directly, or in case that anything goes wrong. If your render doesn't finish and you don't get a video at the end, you can always activate this option. So it will, and you will need to name the new render in the same way as the previous one. It will check for the folder of the frames that you had saved in the past as PNGs. And any frame that it had already rendered, it will skip, and then it will only do the ones that is missing to then compile a video for you of the actual animation. That's pretty much everything to get some nice, quick, high fidelity visuals from EDEM. It's pretty straightforward. There's possibility as well to go into more advanced options, but for today, I think that's a good starting point. And hopefully many of you find it useful and are able to take that next step when it comes to displaying your EDEM results. Any more questions?
So Nacho, we have one more question. Well, a couple. There is one where they're asking if we can rotate the geometry when creating the video. And I think you explained that before, and we could see in the applications where, yes, you can rotate it, have different camera angles. But the next question is, can you actually see particles attribute as velocity in Inspire Studio?
Okay, I'll take both because there's a little thing to add to the first one. So yes, you can have camera movements. Now, they don't work in the same way as they do in EDEM, that you can move the camera manually with your mouse while it's recording. The way that you do this, and this is getting more a bit more in depth, but happy to do so, would be with a path animation, for example. There's two ways to do it. The simpler one would be with a path animation, is how it's set it up for the off-road mobility track. So if we create an additional camera, so we have a list of cameras over here, we can duplicate the one we're on at the moment. And then if we go back into perspective, we see our camera here, the one that I just created, little camera. You can change the position, move it around, and so on. But the way that you could potentially have the camera move around the object is you could draw with the curves tool or the sketching tool a curve around with whatever path you want. Could be like always on the same plane or going downwards, for example. And then in the animation, you define a path animation for this object along the path that it would be the curve that you set up. And then the camera is going to follow during the seconds of animation you actually have. the path that you have set and render the animation in that way. Hopefully that it's an introduction to how you can do it. Hopefully it helps. There's always more that can be explored in that sense. The other one was, what was the other question, Cesar?
Was if you can see attributes, for example, velocity, when rendering the particles.
Okay, so that one briefly was covered at the beginning. So the way to actually look at, yeah, good point. The attributes at the moment would be with this Animesh option within the analysis tools. This is also where we find the particle geometry to change a particle to template. So it's a matter of choosing the objects, importing our template, so it's floating around. We choose that as the geometry, and it will center and auto-size it for each particle. Just quick run through. Now, for checking the attributes, we would go into the Animesh. Apologies. Select an Animesh object, and then go into Animesh. And from here, you get the channel would be the attribute itself, which at the moment we have velocity and angular velocity, as I was saying, for multispheres. And from it, we get this display of coloring based on velocity. And we can set our limits, for example, to be 2 to 60. I might have been a bit extreme. And also they're all on the belt, so there's not a lot of variability. Let's do it with the polyhedrals. Now, as far as I'm aware at the moment, it is not possible to get the final rendering with the attribute. It's something that it's in the list of things to look into. So I believe it's only possible to get this in the preview render, which would be, unless I get surprised, doesn't look like it, in this render mode. So it's either here or in the normal display that you can visualize the attribute. Ideally, in the future, it will also be in the rendering, full rendering mode, but it's not possible at the moment. There's no more questions. Just some closing words from my side. Thank you very much for listening. Hopefully you found it interesting. If you have any questions later on, you can always get in touch with us through support. But yeah, hopefully you found it interesting. You can take your simulations to the next level when it comes to visualization. Yeah, thank you very much.
Yeah. Thank you very much, Nacho, and thank you very much, everyone, for attending today.
Have a good day.
Yes.
Thank you.
Bye now. Thank you.